So we are going to start one example. We have 4 alphabets A, B, C, D, all are different. And how many codes we can make using out of 4 2 alphabets only 2, right? So I am giving one example. We have to use 2 code alphabets, right? So out of 4, this can be filled, this place can be filled in 4 ways. This is fundamental theorem of counting, right? And different, what we are using in this place, we are not going to use in this place. So we have 4 choices. But here, for this place, we have only 3 choices, and this is 12. So if you want, you can try. This can be AB, AC, AD. Now these are arrangements, right? Not the selection. We are selecting and we are arranging also. Because we are, if we write down AB, so BA is a different code, right? So this is one. Then BC, BD, BA, right? Then we can start with C, CD, CA, CB. We can start with D, DA, DB, and DC. All are different. So how many codes? Out of 4, how many are we are taking at a time? 2 at a time. Any 2 at a time. So we note down this by 4P2. Like this. This is a symbolize. Out of 4 objects, we are using only 2. Now, how to get the formulation of this, right? So what is NPR and what is the factorial notation and all these, right? Now we are generalizing this. Out of 26 English alphabets, right? So if we are going to choose 2, this is the total number of objects. And we are taking 2 at a time, right? So first choice will be, we have option 26 options, but the second choice we have only 25 options. So if this is n, total number of objects is n, and out of that 2 at a time we are taking, so we are, next one will be n minus 1. This is 2, but this here is 1. For example, another example, out of 26, if you select 3 and making a code, so it will be n number of first choice, now see, this will be 26, 25 and 24 now, right? So if total number of object is n, so next choice will be n minus 1 and this will be n minus 2. 3 here, 2 here, ending with 2 here. So if this is 26, this is 26 minus 1, this is 26 minus 2, right? Okay, now there is a symbol factorial. Now suppose we have 3 objects, like this. If I ask you 0 arrangement, we are not going to arrange, but there is one arrangement is already here, means we are not going to change this. So the factorial 0 makes 1, and out of n, n minus 1, n minus 2, n minus 3, we can go to n minus r, suppose r at a time we are taking. So next one will be n minus r plus 1. One more. If this is 4, 5, right? So we will stop at 1 less than that, right? So into 4, 3, 2, 1. If we are taking all at a time, all 26 at a time. Got it? For example, we have 4 letters A, B, C, D. And taking 4, how many arrangements we can make? Right? First choice, 4. Second choice, 3. Third choice, 2. And last will be 1. We can write down A, B, C, D. We can write down A, C, B, D. We can write down A, D, B, C. So for this place, we have 4 choices. We can take A, all A's arrangements. We can take B, all starting with B, with C, with D. So how many this will be? 24. So if we have n objects, so n into n minus 1, n minus r, up to 4, 5, 3, 2, 1. And this is denoted as factorial n. Means starting with n up to 1. Right? And for example, factorial 7 is 7 into 6, 5, 4, 3, 2, 1. Right? Now, coming back to the, not coming to the factorials, properties and all these things, right? What is putting r equal to 0, what will be the, now how we are going to formulate NPR. I am taking an example of 7P2. Means we are going to write down a code, suppose, out of 7 objects, taking 2 at a time. 2 at a time and 2 different at a time, right? Example, A, B, C, D, E, F, G. 7 total number equals taking 2 at a time. AB, AC, AD, AE, AF, AG. BC, BD, BE, BF, BG. Right? Similarly, BG and one more, BA. CD, CE, CF, CG, CA, CB. Right? Only taking 2 at a time. So we actually, the counting fundamental theorem of counting says that the first choice will be out of 7 choices, and next choice will be 7 minus 1, that is 6. So we have 42. We want to change this into a factorial notation, right? If it is 7p2, so we can write down, okay, this is 7 into 6, that is 42. To change this into factorial notation, the larger number is 7. 7, let us write down this, because then in that case we can write down factorial 7 here. 3, 2, 1. But this much we don't have. We are adding this, manipulating this. So divide this by, now this is equal according to our 7 into 6. So this will be what? 5. Factorial 7 upon factorial 5. And what is factorial 5? factorial 5 is factorial 7 minus 2, right? So we are formulated. N general, total object n, taking r at a time, factorial n upon factorial n minus r. There are simple properties that factorial 7 plus factorial 8 is not equal to factorial 15. That's very easy to prove, because factorial 7 is 7 into 6 into 1 up to 1, and this is plus 8 into which is not equal to factorial 15. That you can prove, right? So based on, so we have formulated a number of arrangement out of n total objects taking r at a time, right? Not all at a time, r at a time. So this is factorial n upon factorial n minus r. That's all.